We are on to Chapter 6. This is Algebra 1, Lesson 6.1. So we are going to start with our warm-up before we do anything else. And the first part says to evaluate the expression for x equals 1 and y equals -3. That means we're plugging 1 into x and -3 into y and seeing what value we get. So for this first expression, I have x minus 4y. So I'm going to plug 1 into x minus 4 times, I'm going to plug -3 into y. So that makes y plus 12 because it's a -4 times a -3, and then I get 13. For my next one, I'm going to plug 1 into x and -3 into y. So I get -2 times 1 plus a -3. So that makes -2 minus 3, which makes a -5. All right, next part. Write each expression in slope-intercept. So we just got done doing that. So y equals mx plus b. So I'm going to move this x over. So I get y equals x plus 1. For this one, I'm going to move the 2x over. So I get 3y equals -2x plus 6. And then I'm going to divide everything by 3. So I get y equals -2/3 x plus 2. Lastly, I'm going to move this 5y back over to this side because I want minus 5y equals 5x. I want the y on this side. Then I'm going to divide by -5. So I get y equals -1x because this makes 1, but we still have a negative. And obviously there's no b value, so the b value in that problem is just 0. Okay, so for today we're going to look at identifying solutions of linear equations with 2 variables and then solving systems of linear equations with 2 variables by graphing them. So we will go over both of these concepts. Okay, the main vocabulary words you need to understand if you hear them are systems of linear equations and then the solution of a system of linear equations. So here's our definition. A system of linear equations is a set of 2 or more linear equations containing 2 or more variables. So it's basically 2 equations or more, we could have 3, that have 2 or more variables. So like x and y, x, y, z, stuff like that. The solution of a system of linear equations is an ordered pair that satisfies each equation in the system. So if an ordered pair is a solution, it has to be a solution of all the equations. Or in these cases, we're looking at just 2 equations. All right, so we're going to tell if the ordered pair is a solution of the set. So here's the ordered pair. And this right here, we use this bracket to show systems. So here's one equation, and here's our second equation. So we have 2 equations. First, we're going to check if 5, 2 works for the first equation. So here's our first equation. I'm going to plug, this is my x, this is my y. I'm going to plug 5 into x and 2 into y. These cancel. I get 2 minus 2. That equals 0, which is what is on this side. So that is a solution. Now we have to check the second equation. So I'm going to plug 5 into x, 2 into y. We want to see if it equals 13. So we get 15 minus 2, which is 13. So that is a solution. Okay, so since this was a solution of both equations, we can say that the ordered pair makes both equations true, and therefore it is a solution of the system. So remember, it has to work for all the equations in the system. Just a hint, if an ordered pair does not satisfy the first equation, like let's say I plugged it into that first equation and it didn't work, there's no point in checking the second one because if it doesn't work for one, it's not a solution of any of them. So that could save you time. So here's another example. We're going to tell whether the ordered pair is a solution of the given system. So we have this equation and this equation, and our point is -2, 2. So we're going to do x and y. Our first equation is x plus 3y equals 4. I'm going to plug -2 into x and 2 into y. So -2 plus 6, that equals 4, which is the same thing as the other side. So we're good so far. So I need to go on and check the other side. I have -x. So I'm going to plug in a -2 plus 2. This becomes a +2 plus 2, which is 4, but the other side is 2, so it is not a solution of this side. Therefore, this is not a solution of the system because it has to work for both or all of the equations. Okay, now we're going to look at a solution by graphing. So we're going to look at to find a solution of a system of linear equations, you need a point that each line has in common. So in other words, in order for it to be a solution, it has to be where they intersect. Okay? So for example, here's two equations of a solution or of a linear system. So y equals 2x minus 1 and y equals -x plus 5. Well, if we graph them, if we graph the y equals 2x minus 1, we would go down to -1, and I would do up to over 1. So that's where they get this blue line from. And then the y equals -x plus 5, I would go over or up to +5. And then my slope would be down 1 over 1. So that's where they get the red line. And if you notice, they intersect at this point 2, 3. So that point, because they intersect, is a solution of both equations. So we can say that it is a solution. Okay, so again, if we graph the two lines and if they intersect, that is a solution to the system. However, if you guys aren't really careful with graphing your lines and they're not perfect, it's hard to tell exactly what the value is where they intersect. So it's always a good idea to go back and plug that point in to see if it does in fact work for both of them. So I'll show you what I mean on this last example. All right, so we have two equations, y equals x and y equals -2x minus 3. So I'm going to draw my axes here, and each box I'm going to use as 1. For y equals x, my y-intercept is 0, and that's up 1 over 1, up 1 over 1. So my line's going to go like this. And this is where it's really important to have perfect lines. For my next line, y equals -2x minus 3, I'm going to go down to -3. Okay. And then I'm going to go down -2 and over 1, like that. Down 2 over 1. You could also go up 2 and over 1 this way and draw my line like that. So the point that I think they intersect at right there is -1, 1. -1, -1. Okay? So that's where I think they intersect. Now I'm going to check by plugging them into the equations. So if I plug -1 into y and -1 into x, that works. Now I'm going to plug it into the second equation. -1 equals -2 times -1 minus 3. And I get -1 on this side. So that is the solution because it's where they intersect. And again, I checked by plugging them into both equations. So that is all.